Uh, my name is Привітання, Vitam. Hi. My name is Alexander Lomau. Alex. I'm from Belarus, and I'm working as a developer for 5 years, almost. Mostly I work as a web developer, and I'm a member of Belarusian Ruby user group, and now I work with Foundry in Altoros. Being a web developer, from the start I worked in a small teams which consist of 3 or 2 sane human beings, and everyone in a team could deploy everything, and everyone could use Capistrano or even write Perl scripts. But then I moved to larger teams, and there, if you could deploy something and could do it better, you was asking about it all time. So they could say, come on, you can deploy it, I know you're smart, let's do it on Friday. And sometimes bad things happen after Friday deploys. The problem was that not all programmers in these teams could deploy, manage, or see what is going on in the infrastructure. So the problem was, I like the metaphor that Jordan Cicel introduced in PuppetConf. He told that he felt as a human keyboard. It's like a device between programmers and infrastructure, which is used like a keyboard or something like this. So being a lazy developer, I fell in love with the Heroku way of deploying. It was the first time I have seen it. It was like enlightenment, and for the rest of career, for the rest of my life, I thought that it's one right thing. So Git push is much more simpler and faster than managing everything with management content. With doing infrastructure. So yesterday, approximately in at this time, Piotr Baranovsky talked about all this stuff with PaaS. Thank you, Piotr. I guess I can skip this slide now. So with PaaS, developers can easily deploy, scale applications, monitor them. Also, they can add external services, and they can leave me alone. So after some time, open source platforms came up, and it was like an answer to my prayers. So the solutions with customers who didn't want to go to Heroku was solved. There was many reasons of that they had. The customers wanted to deploy to their own servers. The customers wanted to have control over infrastructure. Also, the costs of Heroku was not so low. And in my experience, there was only one project that ended up with production in Heroku, and it was rather fun developing it. So talking about origins of Cloud Foundry, we can say that the story starts at 2007 with cloud tools. It was the project that was developed by enthusiasts, and then commercial version of cloud tools came out, and after that Cloud Foundry as open source project was released. So the hot moment on this story was in 13 year. So when Pivotal was formed by VMware and EMC, and Pivotal is the most powerful in Cloud Foundry, powerful member of Cloud Foundry community. This year, Cloud Foundry Foundation was announced. This is the it is very similar to Apache Foundation. It gathers companies that develop ecosystem and work with this technology and making common funds and so on. So there is a list of companies that entered this foundation. You can see on the top the giants of IT world. So also there is a company I work in here, and I will tell you about insights of this thing. I didn't find a 3D diagram of these things, and I draw myself in AWS style. Talking shortly about it, there is a heart of Cloud Foundry. It is called DAA. It hosts and manages containers with application instances. So a DA is a web component, so you can with its API, and it manages Warden, which is wrapper of operating system for the DA. So DA is written in Ruby in Sinatra, so it's very easy to tweak it to for use you want. So other crucial component is messaging bus. DA forms headbits of every container, telling that it is alive, and so every component could know that applications are alive. So all user and developer traffic goes through router that is one endpoint, open endpoint in this cycle. Router knows from application from messaging bus, and if application stops, informs messaging bus about deliver messages to messaging bus. Router forgets it, and it doesn't provide any traffic from user to these containers. So there is a login server from there is login server to allow developers to authenticate themselves, and there is a cloud controller that manages everything, almost everything in this cycle. And there is health manager that listens to heartbeats of applications and tell cloud controller if something is wrong. So you can also add external services with Service Broker. Service Broker is a simple web application that that provides cloud controller information about service and binds the servers with containers from by providing environment variables. There are lots of service brokers. For instance, there is even a broker for GitHub that creates account on if you request it and manage it. Okay. Also, Foundry provides API that can be used by different languages, and there are lots of wrappers. And there is a Ruby code here that provides autoscaling for application if its CPU load is more than some threshold. So it's easy to write your own components that will be working in this cycle. Cloud Foundry uses its own tool that is called Bosch to deploy it to main known infrastructures. So there are several variants of this tool, and I work with it almost a year, and it is, I would say that it's orchestration, cloud orchestration tool that allows you to create virtual machines and describe them without any complexity. So currently, for now, you can see the Terraform project, Juju project. The Bosch do the same job, and also it can manage applications and manage virtual machines and rise them up if something is wrong. So what is Bosch? Bosch tends to be EAS independent. It uses CPI. It's wrapper under EAS, and there are official CPIs for AWS, OpenStack, and VMware products. Also, I deployed Bosch to Google Cloud Engine and other not known American hosts. So Bosch takes three components, its stem cell, deployment manifest, and release, gathers them and make your infrastructure. So the only thing you really need is a manifest. All other stuff can be provided from the community. So deployment manifest looks like YAML file, and it describes networks, resource pools, and jobs. Jobs, in fact, are the machines that are run into the cloud. You can describe several tasks for these jobs, and they will be run there. So stem cell is an image that is EAS specific, and you can build your own stem cell. And there are two main official releases of Stem Cell. They are for Ubuntu and CentOS. So release are the description of sources that should be used to build your packages. So there is no, the good practice in Bosch is not to use packaging system and build everything from sources. So release contain all these sources, and sometimes releases could be really huge, and it could take time to deploy them. Talking about Bosch manifest, I wish to show you a SPIF template tool that helps you to combine different parts of YAML and create your manifest from different files. It's very comfortable if you have very large infrastructure. If you need to scale your jobs, you need only thing is needed is to create more, is to tell Bosch to use more instances and run Bosch deploy. Bosch automatically will find out what is your infrastructure and what he needs to do to transfer it to desired state. What is microBosch? MicroBosch is used to deploy Bosch, initial Bosch machine in infrastructure. In fact, it rises Bosch on your machine, makes SSH tunnel to the machine in infrastructure, and deploys Bosch with Bosch from your machine. So that's the idea, like little bit like Chef Metal do. So Bosch Lite is a very useful tool if you want to try out Cloud Foundry on your machine. It uses Vagrant, and you can simply run Vagrant up and you'll have Bosch installed, and after that you'll need only some steps to get Cloud Foundry. So, I advise you to use it if you want to try it out. So there are lots of benefits of this advantage of this tool. There is a simplicity and automation, and you get control over architecture, and this is really cheaper than Heroku. And if you, in my experience, if you use something like 20 workers in Heroku, you have to consider to switch to open source PaaS solutions like OpenShift or Cloud Foundry. And there is high availability there because every component goes in cluster, and you can kill almost every component, and it will still work, except router, I guess. So containers are also great tool. There is a stack that use Docker there, and also there is much of thing to learn from this tool. Particularly me, I learned different language technologies. There is a Spring framework there, Go, Learn. There is something in Ruby and Python. So at this time, there is new version of Cloud Foundry. The new version of Cloud Foundry is getting out, is prepared. So and there is a good talk that shows that that was done wrong, and what new approaches will be applied and how they solve problem. If you even not confident with Cloud Foundry, you can watch this video to see how microservices can be implemented. So other things the other thing is that distributed computing is always a challenge and science and fun. So you can get a lot of theory from there, and I suggest to take a look on this site. There are lots of interesting information there. So talking about similar products, there is OpenShift, as you heard yesterday, and there was a paper from Altos half a year ago, I guess, and you can check it out if you want to make a choice between these two between these two products. So now you can ask me questions, or you can ask me a question later after the talk.
Okay, do you have any questions to Alex regarding Cloud Foundry? Okay.
I don't crash cars and I don't have scary voice, but
okay, so you can catch Alex somewhere.